So today what we're talking about is rational functions. Okay? Example 1. We do not need a calculator, but we can do it on a calculator, okay? But before I do anything, what I need to know is this. First of all, x cannot equal 2 and x cannot equal -3. Capiche? Everybody agree with that? From 2, I got 2 minus 2 is 0. Bad news for Cookie Monster. -3 plus 3 is 0. Bad news. Okay, now, because I can cross-simplify the x minus 2's, right, then I know for sure that I would have a whole at 2 something, right? I'd have an asymptote at x equals -3. Okay, and I'll just let you catch up for that, okay? Since that one's removable, since my x minus 2 is removable, that's my whole. If you can get rid of the problem, if you can remove it, that's the whole. If you can't get rid of it, you're stuck with it, it creates an asymptote. So before I do anything on this graph, I'm going to go to -3, and I'll put in my asymptote, okay? All right, like boom, boom, boom. Okay, right like that, okay? First thing I'm going to do, should I use a darker pen? Let's see, probably pink. Can you see the pink better? A little bit better. Now, I know that I could graph this, and if I were to graph it, it simplifies into an x squared minus a 1x minus 2 over an x squared plus a 1x minus 6, right? I just foiled that in my head. I just did a little foil of this in my head. It makes it easier for me to graph on my calculator. Okay, I already know what it looks like, but I know the way you guys work. You're probably going to want to graph it to secure to make sure you're doing it right. Okay, am I going too fast? Am I going too fast?
Yes.
Okay, I'll slow down for a second, okay? Okay, so I just foiled this because I want to graph this. I'm going to put this in my calculator, so I'm going to go ahead and type it in with parentheses. I'll go y equals. I'll put on the side, Renee, am I in your way if I do it right there?
Oh, good.
Okay, so I go my parentheses. Oh, x squared minus x minus 2 divided by parentheses x squared plus x subtract 6 and graph it, okay? Okay, and there's my asymptote, -3. That makes sense. It does. So I know also at 2, it looks like 2 something. I'm going to put my whole. Okay.
Hey, Mr. Davies, how can it be a whole and an asymptote?
Say that again.
How can it be a whole and an asymptote?
It's not. The -3 is the asymptote and the 2 is the whole. Here's my whole, and here's my asymptote. I'll circle them. How's that? Does that help if I circle them? So here's my whole at 2 something, and here's my asymptote, -3. Now the graph looks something like this. I know I can get it from my calculator. Something like this. And it goes something like this, okay? There's my graph. Okay, now, what's this value here? Well, it's 2 something, right? Let's do what Tamley suggested. Let's cancel, cancel, and rewrite this as f of x equals x plus 1 over x plus 3. Okay? I do the cancel, cancel, right? Cancel, cancel, right? Okay, how am I doing? Now, okay, can I plug 2 in now? Can I plug 2 in now? And if I plug 2 in, I'll get its corresponding y value. Even though it's a 0, even though it's a whole, we'll know where to put the whole. Let's say this again. Once you get rid of its problem, you can plug it in. Once you cancel out its problem, you can plug it in. Even though it's a whole, you can find out where the whole is. Where's the whole at? Well, we plug in our 2. So I'll say, all right, f of 2 is really 2 plus 1 over 2 plus 3, which makes 3/5. So my whole is at 2, 3/5. That's the coordinate of my whole. My asymptote's just a line, okay? We just did a little bit of calculus without doing calculus. I love it. We're a bunch of smarties, aren't we? Okay, Natalie, where you at? So what I did was, once I did what Tammy likes to do, cancel. You guys agree, cancel, make it easier. I'd have x plus 1 over x plus 3, right? Now I can plug in the 2. I can actually plug in the 2 without having a problem. So I plug in the 2 and I get 3/5, and that is the location of the hole, okay? All right, now, example 2. Okay? Natalie, I'm going to wait for you, okay? Do you need to sit closer? You sure?
Maybe it comes in this table.
Okay. I'm going to move on and I'll help you, okay? All right, this is what this graph looks like. Looks just like this. Has asymptotes here and here, okay? This is called our parent function, okay? Okay, oh, I did make a mistake. Okay, here it is on my calculator, okay? There it is on my calculator. Okay, that's our parent function. We have asymptotes, horizontal. Asymptote at y equals 0. And we have a vertical asymptote at x equals 0, okay?
So does that mean it's not going to touch zeros?
Say that again, please. The answer is totally correct. Say that again.
So that means it's never going to touch zeros?
Never touch zeros. Because if it does, guess what happens? Cookie Monster's going to freak out because if it's 0, guess what's going to happen, Tammy? You're going to divide by 0, and you can't divide by 0, can you? Okay. So now, if this is our parent function, let's draw it again. Check it out. Okay, x cannot equal -2. Agree? You guys agree with that? So that means I should have a asymptote at -2.
That's not -2.
Oh my goodness gracious. How about there instead? My bad. It's Monday, huh? Good thing I own whiteout, huh? And I have a horizontal asymptote right here. So I'm going to take this graph, my parent function, and just move it. It's going to look like this. Do you want to see the dance? Do you want to see the dance? Do you want to see the dance? Of course you want to see the dance. It's on the inside. It's in the parentheses, right? So which way did I move the graph? I went the opposite direction, didn't I? So I took this graph and I moved it back 2, didn't I?
But you also did dance.
Yeah, I did the dance.
Yeah, there you go.
Which way am I going? There you go. Gotta do the dance. Okay. Just breathe. Yeah, Katie. So I just moved the asymptotes, didn't I?
No, you moved it to the other side.
I just moved the asymptote. How about this one? Where are we going to move the asymptotes this way?
You moved them to the other quadrant.
Does it matter?
Oh, there's a second mistake. Doggone it. It does matter. Hey, you know what? Put a negative right here and I'm okay. Put a negative right there and I'm okay. Put a negative right there. -1, now I'm okay. There you go. Okay, how about this one? I'm going to put my asymptotes at +3, +2. Oh, that's really sad looking, but you know, that's pretty sad looking. So what I did, I took my parent function and I moved it +3 and up 2. So I'm going to take this graph and put it here. So I just moved it to +3, opposite, right? Do the dance, and I brought it to. So then I'm going to take my parent function and put it right here. So x cannot equal 3, and that's why I have a vertical asymptote. Okay. And I have a horizontal asymptote at y equals 2, don't I?
Really? Yeah. Like the first one.
Okay, ready to turn the paper? I'll wait for you.
I like the first one. I wanted to be like for 11.
Did you not get? I'm sorry. Good. No, Jake, I'll wait for you. Of course I will. I will wait for you. Of course I will.
I would come to school because I wouldn't be here.
Okay.
But I burned it down.
And if we can get through the next 2 problems, I will beg the homework.
Yeah.
Why not?
Oh, we only have 10 minutes.
All right. Claire wasn't listening.
Yeah.
I'll say it better. I'll say it better. Let's do the next 2 examples, and then we won't have homework.
Yeah.
Right.
But then I heard someone else go, no! And I was like, oh.
That was
Oh. Okay, example 5.
You heard yourself.
Okay, example 5. So, first of all, identify zeros, okay? So, before you do anything, identify zeros. What do you know about zeros? Do you know anything about zeros? Zeros. What do you know about zeros? You know anything about zeros? Besides science. That's when zeros, right? Zeros is when this equals 0. Zeros is when
0, 0, 0.
f of x equals 0. Or they're also going to be x-intercepts. Or they're also going to be x-intercepts. Okay? So before I do anything, let me do a little bit of factoring. So let's factor first. So zeros. All right, so let's go f of x equals, x minus 3, x plus 2. You okay with that? Or x minus 2, okay? So I know quite a bit here. I know quite a bit. 0 on the top is 0. 0 on the top is 0. It's like this. Cookie Monster has 0 cookies and 10 friends. Each friend gets 0 cookies. That makes sense. It makes sense. 0 on the top is 0. So my zeros are at x equals 3 and x equals negative 2. Right? 0 on the top is 0. 3 and negative 2. So I can go to 1, 2, 3 and put an x-intercept, and I can go to negative 2. Okay. 0 on the bottom is not good. Cookie Monster has 10 friends and no cookies. No, I said that wrong.
No.
Yeah, he has 10 cookies, no friends. How do you divide the cookies up, right? Right. So, x cannot equal 2. So we're going to have an asymptote at 2, right? So I'm going to check out, see if this looks like my calculator. Okay. All right. On y equals clear. Oh, I want the other one. Hold on real quickly. On y equals clear that. Let me go parentheses. I need an x squared. Subtract 2x. Subtract 3. Graph parentheses. And then I'm going to have an x. Subtract 2, right? Window. Probably negative 5 to 5 would work. And probably negative 5 to 5 probably work. Okay, graph it. Okay, that's what it looks like, okay?
Whoa.
Alright, so that kind of makes sense to me. It's going to look something like this. And something like this.
How do you find your other two?
My asymptote, right. Great, my asymptote is here. This is my asymptote.
How do you find that?
Great question, I'm going to explain it.
I didn't even find out.
So if I look at my equation, right, if x is 2, we divide by 0, right? If x is 2, we divide by 0, right? Can I cancel that out? Can't. So if we have a divide by 0 and we can't get rid of it, it's an asymptote. If we have a divide by 0 value and we can't get rid of it, it's an asymptote, okay? So, do we have a hole? There is no hole because you can't cancel anything out. So we have a vertical asymptote at x equals negative 2. That's my vertical asymptote. I already had it. Okay. I have zeros at negative 2 and 3. Let me recap. Okay. Find zeros. Zeros on the top are zeros. Zeros on the top are zeros. So at 3, see the 3? And at negative 2. If the top is 0, it's a 0. So if the top is 0, it's a 0. If the numerator is 0, it's 0. If the bottom is 0, it's going to be an asymptote. Unless you can remove it. Then it's a hole. Okay, let's look at the last one. Okay, number 6. So first of all, zeros. Let's factor if we do anything. So I have f of x equals x plus 2, x plus 3 over x plus 2, x minus 2. Okay? What's the first thing you're going to want to do?
You're going to want to subtract x2.
Yeah, you're going to want to cancel that with that. You guys agree?
And that would be your whole, right?
Yes, nicely done. So we know that x cannot equal negative 2 and x cannot equal 2, but because we can remove that one, that's my whole. Totally right. So my whole is right there. That's my whole because I can remove it, right? So at x equals 2, I have a whole. Okay, 2 something. 2 something. Even though it's a whole, it has a position on the graph. Even though it's a whole, it has a place in the graph. We're gonna find, okay? Now, you can't get rid of this one, can you? That's my asymptote. So my vertical asymptote is at x equals 2. So I'm just going to put that in right off the bat. Boom. X equals 2. Boom, 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 boom. I know it's there. I know it's there. Okay? No matter what. I know it's there, right? If you can't get rid of it, divide by 0, asymptote. If you can't get rid of it, divide by 0, asymptote. Okay? If you can get rid of it, it's a whole, right? Now, zeros. It has a 0. It has 1 0. 0 on the top is 0. 0 on the top is 0. So what value right here would make me have a 0? Negative 3. So at x equals negative 3 is a 0. Okay, so boom. I know the graph goes through there. Okay. Now, if we took a look at it on our calculator just to double check and put it in. Let's see. Okay. I do my parentheses x squared plus 5x plus 6 parentheses divided by parentheses x squared, subtract 4 parentheses, and then graph. Let's see what I get. Looks kind of what I thought it would look like, right? So it kind of goes like this. Right? And like this. Now, real quickly, last thing, and I have 2 minutes. Everybody watching?
Yep.
The whole.
So you would plug
Plug 2 into x plus 3 over x minus 2. Because once I get rid of its problem, you can plug it in. Once you get rid of its problem, you can plug it in, right? Oh. Negative 2. How did I miss that? It's Monday. Negative 2. You agree, negative 2? Negative 2. Right, so I'd get a negative 2 plus 3 over a negative 2 minus 2 will give me a negative 1/4. And that's the coordinate of a hole. Pretty heady stuff, huh? Okay, so we won't do any homework tonight. I think we've got